everyone. Thank you, Jimmy. Thank you, Voxel51, and thank you, Harpreet, for this opportunity. My name is Aditi Singh, and I'm an assistant lecturer at Cleveland State University. I will be going to talk about Agentic RAG today. Here's a QR code for the GitHub repo if you've not looked at it yet, and I'll post this later after the talk as well. So, just wanted to get started about like what agentic RAG is all about. So, agentic RAG or agentic retrieval augmented generation has been like a transformative leap in AI because it is allowing us to automate the agents with the RAG pipeline. Right over here, what you're looking at is the overall components involved in the agentic RAG. On top of the piece is the frameworks and stack, which can be used for generating an agentic RAG. Now, over here, you can see we've listed out the RAG challenges, which is hallucination and accuracy, and I'll go over these one by one. So, for the initial point of view, I would just start with what a RAG is, and pretty much now I'm familiar, or pretty much I expect that people are trying to understand what a RAG is doing and why this agentic RAG is essentially important. I would start by saying that RAG is like a three-piece component, like it has retriever, augment, and generation, which essentially starts by, let's say, before incorporating RAG, we had a scenario where we were just using LLMs, which was trained on some prehistoric data. It's not getting trained every single day. So the ChatGPT version, which we are using, or any other LLM, which we are using has been trained on historic date, or the training is not up to date for that piece of information. Or let's say if you wanted to take example of how many planets are there in the solar system, if we go back when Pluto was a planet and now it has become like a pseudo dwarf planet, so those are some examples where RAG can provide an extensive information in the form of, let's say, PDF, Word document. And what our LLM agent would do is it will look into this information, this booklet, which we are going to provide, rather than depending upon that prehistoric data. So this retriever component tries to look into the most relevant piece from our document, or if you've given like, let's say 5 or 10 document, and there you, whatever query you've placed, it's going to do a vector similarity or any kind of similarity match. And then it tries to retrieve that information, augments that with the user query, and then sends it to the large language model. And then your large language model is trying to generate a combined information, including that query which you passed, along with the piece of information which it extracted from that documentation. So you can see that RAG essentially is just like three-piece component, and this is just to get started with how you can incorporate like current information. Let's say you're talking about some insurance policy, and the insurance company has like n number of policies with some already being applied to some users. And for that piece, let's say the insurance company is trying to create a chatbot. Now, the scenario would be that instead of putting up all these customers' information, you kind of remove those information, and then just keep those policies being applied. So the use case could be a user is asking for, or the agent, the customer agent at the insurance company would try to see whether the accident was made, what all policies can be applied in the auto insurance scenario, and then it would just look at the existing possible policies being applied. So that's just like a generic example of how RAG can be incorporated to access the up-to-date information, to access like accurate information. Otherwise, if we do not provide RAG and we depend upon the the prehistoric data that could be just giving us some information which does not exist in real world, and that kind of calls up for the hallucination. So there are like different components of RAG. We start with, let's say, a basic simple naive RAG. Overhead, the only focus is on retrieval and augmentation. The pipeline kind of involves in like loading, splitting your documents into like text chunks, trying to retrieve queries, converting those queries as well, and trying to find like a closest match. And then at the end, pretty much you're completely dependent upon these text chunks. Sometimes there could be an overlap between the text chunks, right? Let's say you wrote like a piece of paragraph, and that paragraph, you're trying to divide these chunks with 4 or 5 characters or 4 or 5 words. Now, there could be a dependency or overlap between those existing statements. And if we completely depend upon these text chunks, there could be a poor retrieval accuracy, that it may return irrelevant chunks, or that overlap is not captured properly, because text chunk is something like you're splitting your documentation in terms of, let's say, lines, or let's say divide those lines in half statement. So that is like the most drawback of this naive RAG, and that's where we're trying to make sure that those connections, the overlap, the repetitions are being taken care of. Next up is advanced RAG, and this is pretty much like an enhancement from the naive RAG, because what we are trying to do over here is we're trying to say that now let's do a metadata filtering. Let's say, depending upon the data, depending upon the topics, depending upon the section, we're going to divide our documentation. Like earlier, we were just giving one piece of data. Now, this could be in, let's say, a JSON format where you're dividing all these topics in different formats, or you're just dividing them in the form of dates. And then over here, we are trying to make sure, like earlier when I said that the chunks were just divided into smaller pieces. Now here, what we want to do is, for better context, we would incorporate like adjustment of like overlapping. And then in advanced RAG, there's also a possibility of incorporating like graph indexing, such that if there are some entities, they have some relationship that is kind of indexed properly. Let's say you're trying to predict a disease, and some of the diseases have like overlap between the symptoms. So with this graph indexing, you can have like symptoms placed on each node, and then pretty much the symptoms, or basically the diagnosis, could be placed connected to all those symptoms. With this one, again, retrieval enhancement becomes like that domain specific, because you can fine tune those models, use different similarity metrics. Just to, let's take the similar example of our diagnosis, where you can use like cosine similarity, Euclidean distance, or dot product. Now, earlier when we were looking at naive RAG, we did not try to like check what was the information generated. So with advanced RAG, there is a possibility that, okay, if my generated output, or whether I could like re-rank those information, like if these are the information which I've got, can I re-rank them on the basis of the user query which was given? So advanced RAG is another, like it's a huge advancement as compared to the naive RAG. The next one is basically the modular RAG, and this is another enhancement. I would say, like, it kind of tries to combine like different retrieval strategies and AI modules. Overhead, you can see that it is trying to integrate like memory into the ecosystem. So we can read the information, re-rank the information, and if possible, like rewriting those generated text. There is a possibility again for searching in that structured information, or the structured document which you have given. And then you can perform like vector retrieval. The memory module could like store user information. There could be like combined multiple query retrieval for, let's say, better ranking. So this is technically most applicable in different domains, because you may have like all these features combined together. And we're not talking about agentic RAG yet. We're just talking about how powerful RAGs are right now. Now, another possibility is in terms of RAG is having like a graph-based scenario. So you can do like the relationship between entities, like I explained earlier, like in a much better manner, like the diagnosis symptoms example which I gave. With graph RAG, it becomes more structured data. It becomes more easier to accurate to retrieve and generate the results. But there comes a limitation that it would be like it would not be that scalable. There would be some need of more like structured graph data, and then it will be harder to integrate. So now I'll start about like our agentic RAG, and let's start first by what does it mean by that AI agent? Like when we are trying to say that agent can be incorporated in the ecosystem, our agent is capable. It's nothing but it is also an LLM agent, right? It is having like some role, some task. So these are like four essential tools which agents can have. Like it can have memory, it can have planning, it can have tools. With memory comes like the information where you want it to have like a short-term memory, which can track down like immediate conversation. Long-term memory would be, let's say you had an interaction between 1 or 2 days back, or let's say even 30 days back. So those are some information which LLM agent would have. If it's an AI agent, then with planning comes like iterative reasoning, query refining process. Tools are something where you are allowing agent to go ahead and perform search like web searches, like perform like API calls, or let's say go ahead and look into or do a vector search. So these four components essentially make our AI agent more powerful as compared to just having one token-based generation. So now what we are trying to do is we're saying that my agentic RAG can be implemented if I have an AI agent in my ecosystem. And the earlier version, I'll just go back to my, let's say, my NIRAG. So in my NIRAG, you can see that it's just like a static flow, like starting from top and goes all the way to the responses. There's no like feedback incorporated. There's no check being done. So right over here with AI agent, with these autonomous intelligent agent, what we can do is we can design about like agentic patterns, like self-reflecting on what did it generate as a response, because it may not be perfect, like the generated response would be correct. So with this agentic self-reflection pattern, the LLM generates a response and then it reflects on its own whether it's correct or not. Now, this reflection is on the basis of going back to what the user query was, to what the context is, and then it tries to provide critique like, okay, this is something wrong, or it want to like rewrite that particular piece. So that's one pattern. Planning is, let's say, we gave a big task to our agent, and now we want it to solve those tasks like one by one. With planning, what can happen is it can decompose complex tasks into like smaller, manageable chunks, and later it can like once it has performed those tasks, it can go back and refine, combine all those tasks together, and try to incorporate those answers better. With tool use, it's kind of the same thing which we have seen earlier, that now in the ecosystem, agents are capable of interacting with the external tools, uh, and then it is capable of getting back the information, trying to make it more responsive, trying to make it more integrated to the workflow. Because earlier, when we had the RAG component, it was just like one direction. Uh, Now, there's also a possibility that this agentic pattern can incorporate multiple agents. Until now, I was just talking about like one agent doing the task. How about we have multiple agents? Like one agent could be like a center agent, could be like a manager agent, and this agent is dividing the tasks to agent two, agent three, and then they are kind of interacting with each other. So there could be another like obviously it could not be like a possibility of like there could be like how the results are getting back together. And how do you merge those results back there? The coordination could be a challenge in multi-agent system, but it does not limit us that okay there would be just one agent. We can have like multiple agents for the need of scalability, because let's say you are planning to create a travel agent and you want to travel from, let's say I'm here at Cleveland, Ohio, and I want to go to New York. How about like I give my agent like can you book an itinerary for me? My agents could be like a central agent, the other agents could look about lodging, could be the other agent could look at what are the things to do. So those can combine by agent one, and then they can form a much better integrated responses. So the question is, if I integrate all this, or if we integrate all these agentic patterns in our ecosystem, what kind of workflow can be achieved? Like how can we create these agentic RAG applied to different scenarios? Like where will we see those agents acting? Um, now, I would just like to give like one information, like this agentic workflow is not like just like only way to do. Um, there these prompt chaining or the other techniques which I'm going to talk about, they're just providing us like glimpse of how agentic RAG could be incorporated, how we can implement those, but it's not limited to just these. So we'll start with this prompt chaining where let's say you start by decomposing our task into like sequential steps where imagine that you have decided to create this prompt chaining application is like you want to create a marketing content generation and then you want to translate it to another language, or let's say even for document writing. um, Now, overhead, what you can see is there is a query that is being passed to LLM, and now this gate is acting as that agent, which basically checks whether the next step is going to follow the next LLMs or the next sequential step or not. So every time an LLM is generating information, the next step is on basis the inputs for the next step completely depends upon what the previous LLM was generating. It is ideally useful for tasks where you have like clean steps. You don't want to have like parallel information. You don't want the agents to do things in like let's say concurrent manner and then try to retrieve result. This would be more of one by one. Let's say generate an outline. Once the outline is generated, now you want to check whether it's a validated outline or not, and then the next LLM will try to expand it to a full document. So this is like one workflow which can be implemented. The other one is the routing workflow. So in routing workflow, this is where we can perform, let's say, concurrent manner. Over here, what we are trying to see is our initial idea is the input. So this is basically a router. This router would delegate tasks to all these three different LLMs. Kind of the scenario which I was talking earlier, like it can be done in a in a concurrent manner. So let's say you are the customer service queries has been requested, and it could be asking like multiple questions about refunds, about what can be other options that customer could get. So these LLM, like each of these three LLM, or let's say even you can have just two LLM, one asking about like what is the refund policy or what are the other options. And the response would again try to look into the results, try to optimize those results, try to check whether uh, those generated can be like a overall those simple queries can be combined together. So this is another kind of workflow which can be implemented in agentic RAG scenario. We do have parallelization workflow, slightly different as compared to what we have seen in the routing workflow, because router here divides those tasks to the three different LLMs. So that is another autonomous agent feature. Right over here in parallelization workflow, what the query is done is the query is broken already, being sent into three different LLM. So that is where the query is divided into independent tasks, which can be done in concurrent manner. But over here at the aggregator side, that's where the AI agent would look at, try to see those multiple responses, and based upon voting and confidence, considering the query, it will be able to like generate a much better response. So we do have like sectioning and voting along these, where one model will handle like one query, another would handle another query, and then at the end, they are doing like the code reviews. Uh, now, there is another technique which is orchestrator workflow, workers workflow. So this is kind of, now some of you may be like, okay, this kind of looks a little bit similar to what that routing workflow was. There's still a difference. If you look at this right over here, we just generated response from those three LLMs. And this is parallelization, which kind of did a little half of it, like it kind of aggregated all those results. So orchestral workflow is a combination of those two. Basically, you are incorporating these orchestrator, which is dynamically dividing those tasks. It's then delegating them to the LLMs. And now these subtasks are not predefined. So the AI agent is essentially planning on how to divide those tasks. Earlier, we were trying to divide the task, but now it's the agent being able to divide those tasks. Um, and then at the end, you can see there is a synthesizer component. So this is another step where our agents are able to combine those results together, and then create a response. Scenarios where this could be applicable could be, let's say, it is able to handle like complex code changes. It is able to handle like more a task, search related task that requires, let's say, gathering and evaluating data from multiple sources. We do have something called as evaluator optimizer. So this is the only workflow where you can see actually there is a feedback being sent to the generator. Until now, we were just looking at the responses, trying to re-rank or trying to just combine those results together. But this evaluator optimizer workflow is the one where, let's say, once the LLM generates a response, there is an evaluator LLM dedicatedly assigned to evaluate the responses. And this could essentially iterate in a feedback or like a feedback loop, just trying to refine those outputs, just trying to refine those results together. The core idea behind having this generator and evaluator is it want to, let's say, mimic human iterative writing or the revision process. So in terms of like key application, again, you can see that there could be a literacy translation where it is like our LLM agent could convert from English to Spanish, or let's say Spanish to English, in a much neater, much simpler way. Um, or it could also be used for evaluating whether the searches are complete as required by the or as the question was asked or as the query was asked. So those were our initial ways how we can design the pipeline and where our agentic RAG component would be used. So this is where we would start essentially about the agentic RAG. So if I have like a simple agentic RAG, I can start with, let's say, taking the input from the user in the form of query. This prompt is basically sent to like a single retriever router agent. And now this agent would essentially decide whether it wants to go to, let's say, one tool, like a vector search, a one vector search or the other the vector search, and then it would essentially go back to data sources aligning with each of those vector searches. So this is just like one another like single agentic RAG scenario where there's just one relation. This router basically decides like which or what would be the tool used. We do have a multi-agent agentic RAG. So this is where, let's say, the prompt when it was submitted, it kind of spans across these distributed tasks, which all these multiple specialized agents can do. Earlier, we were not doing the multiple agentic approaches, but right overhead, this router agent does have the capacity of doing that. Going over to parallel processing of complex query. And each of them can independently look for databases like vector DBs, look for web searches, or even look for like mails or chat. So this has more tool integration and parallel components in this one. The other one is hierarchical agentic RAG. Over here, it kind of uses that multi-agent feature which we saw earlier. So if you have like query, there's master agent, there is a response. So this master agent should be able to interact with sub-agent Y, sub-agent Z, and that's how like it could create that overall hierarchical agentic RAG scenario. Uh, the other one is agentic corrective RAG. So this kind of checks on that self-corrective system, whether the document is relevant or not, and if it is relevant, do we want to have like more refined query, or do we need to have like a web search being done? So this corrective RAG just tries to improve that document relevance and then make sure that your response is accurate. Uh, and then it tries to pretty much perform or use like specialized agent for optimized performance. Like the agents could be context retrieval agent, relevance agent, query refinement, external knowledge agent, or responsive agent. Uh, the adaptive agentic RAG is kind of an enhancement as compared to this corrective RAG. You can see that over here we are having like a query. There's a retriever node which is sent to a graph node, and the kind of an addition on top of that corrective RAG. But over here we are just checking, doing like multiple checks over here, like whether the document is relevant or not, whether it hallucinated or not. So it is now reflecting on its own result. And you can see like it adjusts on retrieval, it judges the retrieval in real time, reduces unnecessary retrieval overhead, because every time we are doing these checks, it is making sure that there is a high accuracy in terms of ensuring precision responses. And then it can also integrate with other domain-specific tools and API. We do have agent graph RAG also, and this is where you can see the database itself is made in a graph format where retriever is being done using that graph database. Re-ranking is being done. So this is where that graph agent G is being used. Agent can just look at it combines the agentic database over here, and then pretty much there is a critiquing module as well, which checks whether these comments were correct or not, and if the generated response is valid or not. If it is not valid, then go back and look into the database again. Uh, Another graph-based RAG is Gear. Gear is slightly complex as compared to our agentic framework for the graph RAG. But Gear is where it kind of expands those basic retrieval, apart from like cosine similarity, to like other base retrieval techniques. There is a graph expansion module over here. So over its expansion, it tries to integrate more like entity relation for retrieval. It tries to incorporate agent-based retrieval, which is like making sure that agents are able to manage and optimize retrieval strategies. And then there is an LLM integration, which synthesizes like those structured and unstructured data. Because the most important problem in any scenario would be we may not have like one simple form of data. It could be structured, it could be in a different, like it could be a JSON format, it would be just like bunch of like, your PDF files. uh, with Gear, it is able to provide like multi-hop retrieval. It is able to provide like it is able to make sure like there is dynamic decision making, higher accuracy and scalability. uh, there is another format which is agentic document workflow. So this is pretty much on the side where you have like this was basically created by Llama Index. So it is introducing like you can go ahead and retrieve like documents by extracting like field information, like key data field information. If you have like invoice numbers, payment terms, that could be just fetched in that particular document. It also allows you to kind of create the tracking of document across the workflow. And then there is like a knowledge retrieval process where it fetches references from that knowledge base. So that, let's take example which I took earlier about the policy. If I have like a reference like this policy was used in a previous customer scenario, then that is kind of information which essentially insurance company would need. Um, and then it also has capability of applying that agentic orchestration where it can apply like business rules, reasoning, and it can integrate the APIs. Uh, and then right over here, you can see there's another like actionable output. So it can produce the information or like the text could be in a structured manner or what that domain would require. Like in our example scenario, it could be something like our patient or the policy making scenario. So these were essentially like I'll not go over like these are basically already being written on the Agentic RAG paper, but just trying to give like an overall summary of what we went over was our agentic RAG, and that's where I go back to this particular image where you can see that in things which we talked about was AI agent can have like these capabilities. They can have tools, planning, task, role, memory. And what we are saying is we are trying to now say that these agent, along with those capabilities, they can perform like reflection, they can do planning, they can have multi-agent, and they can have tools. And along with that, there could be like some patterns like prompt chaining, routing, orchestration. It could have evaluator workflow, optimizer workflow, or orchestration workflow. So with all these components in place, like agent pattern, the workflows, our taxonomy for agentic RAG becomes like single router, multi-agent, hierarchical, corrective, adaptive, agent G, and gear. And with all these feature, earlier with RAG, we were having hallucinations, limited context integration, static workflows, lack of adaptability. But with agentic RAG, because our agents are more powerful, it can do better enhanced decision making. They can have multi-step reasoning and iterative refinement. They can have like real-time data integration because of more capabilities, and that brings the improved accuracy and context awareness in the scenario. So that brings into my talk for now. I'm open for questions, but I'll just keep that QR code for you guys if you have you want to take that piece down.